direct organogenesis and indirect organogenesis. So to produce an organ from an organ, or to produce a differentiated cells, convert them into undifferentiated mass and then back to the organ system. So before moving on to how the explants have to be produced and how we are going to inoculate, before that, preliminarily setting a sterile environment is most important. As we have seen in the previous experiment, you would have seen regarding the media preparation and sterilization technique. In continuation, the place where we are going to do our experiment is most important. So here you will be using your laminar airflow. Laminar airflow, you would have come across this in your microbiology and the principle behind it. So before starting with our experiment, we need to wipe the workplace with alcohol, and once that is done, whatever is required for the experiment has to be placed, and then we'll be oning the UV for 10 minutes and then we'll be proceeding with the inoculation. So for the preparation or for the requirement, okay, the setup comes like that. We'll be arranging the petri dishes in a sequence for doing the surface sterilization. So first plate, it will be having the 70% ethanol, the second place with sodium hypochlorite, and subsequently 3 plates will be filling it up with water for the washing. And the scalpels, blades, scissors, whatever we are going to use for cutting the explants and for the inoculations, these are already sterile one. Okay, again we are placing that in the laminar. The sterile autoclave distilled water is kept. The media in which we are going to inoculate is kept. So once all these setups are ready, again these tissue papers are required. The tissue paper is also a sterile one. So to ensure one more step, after arranging everything, we'll be again oning the UV for another 5 minutes. Okay, and after 5 minutes, we'll be taking the explant inside the laminar and we'll be starting the experiment. Earlier, we have to prepare, or we have to collect the explants. Explants are nothing but the inoculum which we are going to use it from where the cells or the tissues are going to get developed. Now, in our case, we require 2 types. So, since we are doing direct and indirect organogenesis, the one what we are taking over here is the bits of leaf which will be proceeding for the indirect organogenesis, and the axillary region. The axillary region. I'll show you how we have to take the axillary region. So, in a plant, the foremost tip over here has the axillary bud. Okay, so this is the apical meristematic cells. These are the lateral meristematic, and this one is their intercalary meristematic cells. So these parts have to be covered. So we have to can cut this out. Remove all the leaves. Ensure that you are not damaging the meristematic things. So once this is done, the explant for your direct organogenesis is prepared. So this one, this part, okay, this is the apical meristem. These are the intercalary meristems, and to the surroundings will be the lateral meristem. So this is for direct organogenesis, and the leaf bits I have taken it for indirect organogenesis. Okay, for that the callus have to be developed. The callus will be developed in the damaged part. So we are just taking the leaf and creating the damage, so that the damage gets exposed to the medium, and then from the parts wherever it is getting damaged, the callus are going to get developed. So this is how we will be preparing the explants. So once this is done, since this is from the external environment, this has to be sterile. Okay, so what we call it as surface sterilization. So for the first, we have to, before I cut it, I have washed this plant in the running tap water. So after that, I have cut this. Okay, after cutting, this has to be given a wash with Tween 20. Tween is nothing but a detergent, a mild detergent which could be used for the tissues. So you wash the cells or the tissues with Tween, and after Tween wash, Okay, we'll be pouring the water, wash it again, and then we'll be taking it to the laminar. Told you the experiment whatever we have collected, this is a water. I'm adding just 2 or 3 drops of tween to it. Once it is done, dilute the tween, put in your explants, and keep shaking it. So after a few seconds, we are going to drain off the tween, wash it with water, and then take it to the laminar. Continuity with the sterilization. So we have washed it with the tween, and we have already rinsed with the water. Now going in for the surface sterilization steps. Here we have the autoclaved and the sterile equipment, the forceps, scissors, etc. This I have dipped it in the alcohol, okay, to ensure that it is sterile. So I'll be taking the forceps, just show it in the flame. You need not heat it to the maximum heat. Just the ethanol what is binding there has to just evaporate. So show it in the flame, and once that is done, sequentially we are just going to take the explants for the surface sterilization. So I am doing it simultaneously for both direct and indirect organogenesis. So the leaf bits, whatever we have cut it, we have sterilized, washed with tween. Okay, so that I am just amending that in the alcohol. This is a 70% ethanol what we are using here. So in this, it has to be there for 1 minute. So after 1 minute, the next plate is sodium hypochlorite. It could be sodium hypochlorite or mercuric hypochlorite. Anything could be used for this. And depending upon the concentration what we have, depending upon the percentage what we have, the time exposure of that varies. Okay, ensure that the tissues should not go for the charring. It should not burn the tissues. Okay, so the exposure time has to be optimized before we put in the tissue. So for us, it is 4% which is available, for which we could give around 5 minutes. So I am just taking it from the alcohol, suspending my tissues in sodium hypochlorite. So in